Srinivas Gowda, working as an assistant professor in Institute of Aeronautical Engineering. Today we'll discuss the relational data model in DBMS. We'll try to understand what is a relational data model and how can we implement in SQL Server. Now, first let us understand what is relational model. Relational model (RM) represents the database as a collection of relations. Relational model represents the data as a collection of relations. A relation is nothing but a type of values, table of values. A relation is nothing but a table of values. Every row in the table value represents a collection of related data values. These rows in the table denotes the real world entities or relationships. Okay, the relation is nothing but table of values. Every row in the table will represent a collection of related data values. These rows in the table denotes the real world entities or relationships. A table name and column names are helpful to interpret the meaning of the values in each row. The table name and the column names are useful to interpret the meaning of the values in each row. The data are represented as a set of relations. In the relational model, the data are stored as tables. However, the physical storage of the data is independent of the way the data are logically organized. Okay, some of the popular RDBMS things are DB2, Informix. They are from IBM. Then we have Oracle and RDB from Oracle. We have SQL and Access from Microsoft Corporation. Okay. Next, we will try to understand few concepts of relational model. A table will contain rows and columns, right? Customer, in this example, customer ID is a column, custom name is a column, status is a column. These three are the columns, whereas rows 1, 2, 3 represents 3 different values stored into the database called customers. Okay. Now we'll see few keywords related to tables here. First, attribute. Each column in a table is an attribute. A customer ID, customer name, status is an attribute. So these three are an attributes. Each column in a table is called an attribute. Attributes are the property which defines a relation. Okay, customer is a relation. Or what are the various attributes which customer will have? Customer ID, customer name, status, and so on. So these attributes are a property which defines a relation. Student, roll number, name, email also. We have finished attribute. Now let us see what is a table. In the relational model, the relations are saved in the table format. The relations are stored in the table format. Attribute is nothing but a relation. When the relations are stored in the table format, which is in table, it is stored along with the entities. A table has two properties, rows and columns. Row represents records and column represents attributes. Row represent records. See, 1, 2, 3 are rows. Okay, this will represent the records. The column represents attributes. Customer ID, customer name, status will give are nothing but attributes. So we have seen what is a table, what is an attribute. Now let's see a tuple. Tuple is nothing but a single row of record which contains single record. Now 2 is a record, 3 is a record, 1 is a record. A single record is nothing but tuple. Next, the relational schema. A relation schema represents the name of the relation with attributes. The relation schema represents the name of the relation with attributes. Next, customer along with customer ID, name, status will give me the relation schema. Degree, the total number of attributes which in the relation is nothing called degree of the relation. Degree is nothing but The total number of attributes which in the relation is called as the degree of the nation. In this case, my degree would be 3 because I have 3 columns here: customer ID, customer name, and status. These 3 will be the degree. Okay. Next, cardinality. Cardinality is nothing but the total number of rows present in the table. In this case, there are 3 records. So my cardinality would be here 3. Total number of rows present in the table. Column is nothing but attributes. Column represents the set of values for specific attribute. Column and this column and attribute are similar. Next, relational instance. We have seen earlier relation scheme is nothing but the name of the relation with the attributes. Now we see relational instance is a finite set of tuples in the RDF system. The relational instance will never have duplicates. So each row would be a unique. Each row would be a unique. So relation is set of tuples, set of 1, 2, 3. These 3 would be the relational instance. Yes, the relational key. Relation key. Every row has 1, 2, or multiple attributes, which is called as a relation key. Each row has 1, 2, or 3 has attributes, and this is called as a relation key. My customer ID 1 is unique. It can be a relation key. Next, attribute domain. Every attribute has some predefined value and scope, which is known as attribute domain. Attribute domain nothing has predefined value and scope, which is known as attribute domain. Right? Good. Next. Now we will see few relational integrated constraints which SQL Server provides. Next, first we will see the relational integrity constraint is referred to conditions which must be present for a valid relation. It says that the relational integrity constraint is referred to the conditions which must be present for a valid relation. These integrity constraints are derived from the rules in the mini world that the database represents. There are many types of integrity constraints. The constraints on the relational data management system is mostly divided into 3 categories. There are many constraints, integrity constraints, but the constraints on the relational database management consists of 3 main categories. One is the domain constraint, the second is the key constraint, and the referential integrity constraint. Let us see each one of them in detail. The domain constraint, the first constraint is this constraint can be violated if the attribute value is not appearing in the corresponding domain or it is an appropriate data type. The domain constraint can be violated if an attribute value is not appearing in the corresponding domain or it is not a proper data type. Domain constraint specifies within each tuple the value of attribute must be unique. This is specified as data types, which include standard data, integer, real numbers, characters, boolean, etc. When each tuple should be unique, it says that. Now, for example, I say create domain customer name, check. I pass a value and it should be not null. That means an example shows that I'm creating a domain constraint which checks that the customer name is not null. This is the domain constraint. My domain is the customer. I'm saying here my customer name should not be empty. So I'm creating a domain constraint saying that the name of the customer should not be empty. This is the domain constraint. Let us see the key constraint. A key constraint is an attribute that can uniquely identify a tuple in relation is called a key of the table. The value of the attribute for different types, for different tuples in relation has to be unique. An attribute that uniquely identifies a tuple in a relation is called the key of the table. The value of an attribute for different tuples is in the relation has to be unique. For example, in the given table, the customer ID is the key attribute of the customer table. It is mostly likely to have a single key for the one customer. Customer ID 1 is the only for customer name Google. Okay, for Google we have customer ID 1. For Amazon, we have 2. For Apple, we have 3. So customer ID is the key attribute, and it can be it can be a primary key or unique key. And this is the key constraint. Earlier we have seen domain constraint. Now we have seen the key constraint. Now let us see the third type, which is referential integrity constraint. This is nothing but which deals with primary key and foreign key. So we'll see through example. The referential integrity constraints is based upon the concept of foreign keys. A foreign key is an important attribute of a relation. Foreign key is an important attribute of a relation which should be referred to in other relationships. The referential integrity constraint states happen when the relation to the key attribute of different or same relation. However, that key element must exist in the table. It is nothing but a foreign key, and these will refer to different or same table, same relation. Suppose, but the key should be existing in the table. Okay, let us see an example. Now we have here 2 tables. One is the customer table, and second is the invoice table. Okay, in the customer and the invoice or billing. Okay, the tuple for the customer 1, which is the primary key, the customer ID 1, has a corresponding 2 records in the invoice. The customer 1 is referred twice in the billing section. So we know that customer name Google has billing amount of $300. There are 2 records in the child table. Invoice is the child table, where the customer ID is the master table. So we are referring to the customer ID as a referential integrity in the second column, and it has 2 rows, 2 unique values, one for $1,000, second for the $200. Totally, for the customer name Google, we have invoice amount of 300 rupees. This is how we refer a primary key and foreign key relation. Okay. Next, the various operations in the relational model. 4 basic update operations are performed on a relational database model are insert, update, delete, and select. Okay, insert is used to insert data into the relation. Delete is used to delete the tuples from the data. Tuple is nothing but a single row of record. Modify allows you to change the name of some of the active existing tuple. Select allows you to choose a specific range of data. Whenever one of these operations are applied, whenever one of these like insert, delete, modify, and select are applied, the integrity constraint specified on the relational database must never be violated. The integrity constraints between on the table cannot be violated. Now let us see the insert operation on the RDBMS. The insert operation gives the value of an attribute for a new tuple which should be inserted into the relation. My existing is have 3 records. I'm trying to insert a 4th record, Alibaba. So using insert, I am inserting the new relation as 4. Okay. Similarly, for update, I'm saying you can see that in the below given relation, customer name Apple is being updated from inactive to active. This is the insert we have updated. Now we see the next 2, just delete and select. To specify deletion condition of the attribute of the relation, selected tuple must be removed. In the given example, customer name Apple is deleted from the table. The delete operation could violate the referential integrity of the tuple which is deleted, which is referred by the foreign key from other tables in the same database. Suppose if this Apple is being referred in other tables, if you try to delete it, will give you an error. As it is being referred in other tables. First we have to delete the child table, then come and delete the main table. This is the delete operation. Similarly, we have a select operations. In the select, we say what columns you want to view in the data from the real set. Therefore, I say select A, comma B. It will give me the values of A, comma B. It will not give me the other column C, comma D, and then out. If I say select star, it will give me all the rows from the table. Now, let us see the best practices for creating a relational model. Data needs to be represented as a collection of relations. So the best practice one is the data needs to be represented as a collection of relations. Each relation should be depicted clearly in the table. Should be depicted clearly in the table. A row should contain data about the instances of an entity. Rows should contain data about the instances of the entity. Column must contain data about attributes of the entity. The attributes like customer is an entity. It has three attributes: customer ID, name, and email. The column will contain the attributes, whereas the actual data for these customers, Apple, active, inactive, all is the rows. The cell of the table should hold a single value. For best thing is that the cell of the table must always have a single value. Each column should be given a unique value. The number, name, age, sex, then course. We can't have two age columns in an attribute. No two rows can be identical. We can't have two same records in the database, which is a bad design. The value of an attribute should be from the same domain. The value of an attribute should be from the same domain. Like we're talking about customer, you should have the value of customer details in one attribute, like customer name, customer ID, and etc. We can't say you bring some other attribute to a value here. The advantage of using relational model. First, we have seen earlier the best practice. Now we will see the advantages of relational model. Simplicity. A relational data model is simpler than the hierarchical network model. Simplicity is the relational data model is simpler than the hierarchical and network model. Structure independence. The relational database is only concerned with the data, not with the structure. This can improve the performance of the model. Structural independence is only concerned with the data, not the structure. And it is easy to use. Relational model is easy to use. The relational model is easy as the table consists of rows and columns, quite natural and quite simple to understand. Query capability. It makes possible for a high level query language like SQL to provide complex database navigation. Query capability. Next is data independence. The structure of a database can be changed without having to change any application. The structure of the database can be changed without having any application. Scalable. Regarding the number of records or rows and the number of fields, the database should be enlarged to enhance its usability. Scalable is based on the number of records or rows, the database can be enlarged to increase its usability. What is that? We have seen the advantages of relational model. Let's see the disadvantages of using relational model. Few relational databases have limits on field length which cannot be exceeded. Few relational databases have limits on field length which cannot be exceeded. The relational database can sometimes becomes complex as the amount of data grows and the relation between the pieces of data becomes more complicated. Complex relational database systems may lead to isolated database where the information cannot be shared from one system to another. Suppose there is some complex database may lead to isolated database where the information cannot be shared between one system to other system. That is the disadvantage of DBMS, of using relational data model. With this, we complete the last thing is summary. Okay. Let us have a summary of the relational data model. The relational data model represents the database as a collection of relations. Database is nothing but a collection of tables. Table is nothing but a collection of rows and columns. The relational database model represents the database as a collection of relations. Attributes, tables, tuple, relation schema, degree, cardinality, column, relation instance are some important components of relational model. The relational integrity constraints are referred to the conditions which must be present for a valid relation. Relational integrity constraints are referred to conditions which must be present for a valid relation. Domain constraints can be violated if an attribute value is not appearing in the corresponding domain or is not an appropriate data type. earlier we have seen on domain constraint, let's check customer name. Customer name. If suppose we don't give that customer name, then this attribute, this govern constraint will fail. It will fail saying that there is no customer name. Insert, select, modify, and delete are the operations performed in the relational model. The relational database is only connected with the data, not with the structure, which can improve the performance of the model. The advantage of relational model is simplicity, structural independence, ease of use, query capability, data independence, and scalability. Few relational databases have limit on field length which cannot be exceeded. For example, I've seen that varchar and char has the limit of 8,000. We cannot increase more than that. That is one limitation of relational. With this, we complete the relational data model in DBMS. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.